Hi guys, welcome to today's video. So what I want to teach you into today's video is this type of question. How do you do them whenever you see this type of question in your UTME? But before that, I want to implore you to subscribe to our YouTube channel and also like this video and share it to your friends that you are of course doing UTME together. And I can't wait for you to enjoy this video and also try to teach other people this concept. By the way, this is Evan's teaching class UTME tutorial, and this is one of our questions that we're going to be solving in this episode. Now let's look at it. Now whenever you see a question like this, look at it. This is called a velocity time graph. Do you understand? This is called what? A velocity time graph. Now in a velocity time graph, one of the things that you will see in a velocity time graph, this is the velocity time graph. You on your vertical axis, you are going to have your velocity, which is measured in meter per seconds. Do you understand? While on your horizontal axis for a velocity time graph, you will see your time t, which is measured in seconds. Do you understand? Now this is it. The line, that is this line that you are drawing here, do you understand, is like the velocity is increasing with respect to time. Do you understand what I'm saying? The velocity is what? Is increasing with what? With respect to time. Now, when velocity is increasing with respect to time, what do you call it? It is called what? Acceleration. Now, if you look at this diagram, automatically you already know that this will be your what? Your acceleration. Do you get the logic now? Now, that is acceleration. You know, normally, let me divide this for you. Acceleration is increase in velocity with respect to time. That is acceleration. Do you get that? That is acceleration. Now, this question is asking us two things. Let's read the question. The diagram above shows, this diagram shows the velocity time graph of a vehicle. Its acceleration and retardation respectively are option A, 8.0 meter per second square, 4.0 meter per second square, 4.0 meter per second square, 8, 4, 2, 2, 4. Now, look at it. They're asking us to find what we call retardation. Retardation is also called deceleration. Deceleration is the opposite of retardation. Do you get what I'm saying? So it means increase, I say acceleration is increase the velocity with respect to time, right? Now for retardation, it will be what? Decrease in velocity with respect to time. Now the thing is, how do you know the formula for them? Now, even apart from this, now it means deceleration is this place. Deceleration is this place. It's decelerating. What we mean by deceleration is that the speed is coming down. That is, the velocity is coming down. Just like whenever you are riding a motorcycle or a bicycle, you will start from rest. What happens with acceleration is that acceleration will start from rest, right? It will start from initial velocity. While retardation will start from the final velocity and it will end, it will start at initial velocity that is not zero and it will end at the final velocity that is zero. When I mean final velocity that is zero, it means the object is going to come to rest. If you look at this object, it starts from zero, it moves to 80. So it means your initial velocity here is 0 meter per second square, 0 meter per second, right? That's your what? Initial velocity. I hope you can see it very well. Now, when it gets to this place, this is velocity side, this is time side. When it gets to this place, it becomes 80, right? So it means your final velocity is what? 80 meter per second. Do you get? Now look at it. Around this place, the velocity is constant. It does not change. It means the velocity here is 80. When it gets here, it's still 80. When it gets here, it is still what? 80. Now don't forget, I said here that V is 80 meter per second. Do you get? So now, when you now get to this side, your final velocity will no longer be V. Your initial velocity will now become your final velocity, because you are just talking about this triangle. I think you get the logic. I think you are not confused. When you started here, your initial velocity, initial means you start with something. What you start with, that initial, like if I wanted to start a business, my initial capital, what I started with, it means your speed here starts with 0. That's why it is called your what? Initial velocity U. When it gets here, it becomes final velocity. Final velocity. But I've not even started the work yet too. Now, when it gets here, that is constant velocity. Do you get? That's your what? Constant velocity. Now, you know, because the velocity is constant between time 20 to 50, right? Now, whenever you want to do questions like this, you need to know that acceleration is equals to V minus U over T. Now, I already told you that your final velocity here is what? 80, right? So let's put it inside. What's your initial velocity? I said it is 0. What's your time? Your time, you know, you can see now, your time is already here, 20. I hope you understand it. So it will now be what? 20. So what do we have? 80 over 20. We now have what? 4 meter per second square. So that's your acceleration. But it's asked you to find deceleration also, or retardation. So we only find this. We are still looking for retardation. Now, how do you find retardation? You know, I told you, whenever you want to do retardation, you are talking about this diagram. Let me try to use another color so that you can understand what I'm saying. So we are now under what? Retardation. We are going to be looking at this diagram. This is it. When I did this first acceleration, I talked about the first triangle here, right? So if you look at this now, this is 20. Distance between here and this one is what? 20, right? Between here, if you look at the difference, it is 80 minus 0. That's what I did here. Your time is 20. Do you get now? So the same thing with this one now. Now, what is the distance between 50 and 90? What do we have? 40. Do you get the logic now? So this one is what? 40 seconds. Now, what are we doing? Deceleration now will be, let's say it is D. The same thing also, V minus U over T. So what's your final velocity? I say your final velocity will now be this one. Sorry, it will not be, your initial velocity will be 80, because this is the triangle we are talking about. It means your final velocity will become your initial, because your speed, we are assuming as if your speed is starting from this place. So it means your initial velocity will now be here instead of starting here. Do you get what I'm saying? So it will now be 80 meter per second. Do you get now? So it will now be 80 minus, if you get to this place, you will see that the object comes to rest, come back to 0. Do you get? So it means, sorry, I've made a mistake here. Your initial velocity here is what? Your final velocity here becomes what? 0. So 0 minus 80. So that's your initial velocity. So what's your time? I said it to be 40 like that. So what do we have? Minus 80 over 40. So what do you have? 80 divided by 40. So that will be minus 2 meter per second squared. Now, sorry, they made a mistake in the option. There should be minus here. There should be minus here, because retardation cannot be positive. There should be minus here. So, because retardation is always negative. So, our answer is minus 2 meter per second squared. So, thank you very much for watching this video. So, I want to implore you to subscribe to our YouTube channel, invite your friends to this YouTube channel, and I am sure they are going to enjoy this class. Thank you very much for watching. Bye.